Alrighty, let's go ahead and start 9.2, stoichiometry continued. Here we are going to see how to use one-step stoichiometry, and then finally the last problem we'll do is the big old dreaded four-step Stoich problem. This year's chemistry students know them as four-step Stoich. A year ago, 2 years ago, we called it the four-step bridge. Alright, so let us remember. The mass of 1 mole of something is its molar mass. We can figure out how many moles we have of something if we know what its molar mass is, and vice versa. In other words, if you know how many moles of something you have, you can figure out its molar mass. If you know the molar mass of something, you can figure out how many moles you have. Let's take this first question to begin with. If I have 3 moles of water, H2O, how many grams do I have? Well, the question gave us, to begin with, 3 moles of water. It wants us to find out how many grams that is. So that's what we're going to. Let us start with 3 moles of H2O. We need to multiply that by a conversion factor. Well, what is the conversion factor? Well, if you recall, 1 mole of something is equal to its molar mass in grams per mole. Well, what is the molar mass of water? We have to figure that out. Okay? We need to go off to the side down here and figure out what the molar mass of water is. In the formula for water, we have H and O. There are 2 H's. When you multiply it by its mass, and then 1 O will multiply it by its mass. Looking at the periodic table, for the sake of time, I'm just going to go ahead and give you these numbers. Hydrogen is 1.01, oxygen is 16. You would then plug that into your calculator, but again, I can do this in my head. Pause the video if you need to, and plug it in yourself if you'd like. This is 2.02. And 16 times 1, anybody should be able to do that. That's 16.00. If you add that together, how many decimal places are we allowed to have? If I had lined this up a little bit better, you would see that there are 2 places after the decimal for this, 2 places after the decimal for this, so that's the total number of significant figures we're allowed after the decimal. Adding this up, it will come out to 18.02. Okay? So we have over here 1 mole of water is equal to 18.02 grams per mole of water. Okay? In other words, 1 mole of water weighs 18.02 grams. So let's go ahead and plug that into our conversion factor. Or our problem, I should say. We need to cross-cancel the moles of H2O, so that must be on the bottom. I'm going to keep repeating this until you're throwing it up or you can say it in your sleep. When you cross-cancel something, they have to be the same in terms of units. I'm not going to bring the 3 down here, but I am going to bring the unit. Okay? And then it says we are going to how many grams that we have, so we need grams up here. Alright, let's plug in. 1 mole, and then we have 18.02 going with the grams, okay? Now, how come I didn't say grams per mole right here? Well, I technically should have, but that per mole is already taken care of with this mole down here. Okay, so that way they cross-cancel. And at the end of our answer, we're going to be left with grams. Now we're ready to go ahead and plug into our calculator. We multiply across, then divide by the bottom, but you really don't need to divide by 1. It'll just be the same answer. 3 times 18.02 is equal to 54.06. But, ladies and gents, significant figures, okay? Significant figures. This is a definition right here. How many significant figures do I have in this number right here? I have 1. Okay? So therefore my answer can only have one significant figure. To round this off to one significant figure, I've got a couple of options I can write this as. We need to start with this 5 here. I have a 4 next to it. Is that going to round this 5 up or down? Or, better question, is it going to keep it the same or round it up? The 4 is going to keep this the same, so the 5 is going to stay here. Alrighty? It's going to round to just 50. It's going to round to just 50. Another way you could have written this is 5.0 times 10 to the second power. Okay? I'm sorry, times 10 to the first power. Excuse me. That's scientific notation. Sometimes certain chemistry textbooks or certain scientists will automatically resort to scientific notation. To do scientific notation, you would just take an imaginary decimal, move it over one place, and then however many places you moved it, you do times 10 to the, however many number of places, so it would be 1 there. Okay. I wouldn't recommend doing it unless you absolutely had to, but we do need to add a unit to this, and it's grams of water or grams of H2O. And then grams of H2O. Either one of these are correct. This would be a more realistic answer because there's only one significant figure here. Now in the future, some problems may consider this given a counting number, and so therefore you would have been allowed as many significant figures as you would have liked, because remember, definitions or counting numbers have an infinite amount of significant figures, but this problem did not specifically state that this is a counting number. Alright? We may be able to make the assumption that it is in the future, but I'll let you know when we get to that. Alright, that's one-step Stoich. Let's go ahead and move on to the big bad 4-stepper, the 4-step bridge. Okay. Now, we are officially AP students. Okay. So for those of you that last year in chemistry learned this as the broken down method, doing it in 3 separate fractions, one on top of the other like this, or if you recall from 2 years ago, we'd made these little bridges and did the lines like this. We aren't doing that in AP. Both ways will give you the same answer, but we now need to start treating this like grown-up stuff. So we are going to literally multiply 4 fractions together. Alright? This is number 8. This is number 8 of your summer assignment, so I'm going to do one of the problems for you. Using the equation below, determine how many grams of CO2 is made if you break down 4.5 grams of NaCl. Okay? We were given 4.5 grams of NaCl to begin with. Because this is 4-step Stoich, we have to take this to a mole first. Mole of our starting stuff, grams of our starting stuff, 2 moles of our starting stuff. And once we have moles of our starting stuff, we can finally go to the grams of the stuff we're looking for. In this case, it's asking us how many grams of Cl2 can be made, but we can't go from moles of starting stuff straight to grams of starting stuff. We have to go to moles of starting stuff straight to moles of what we're looking for. We have to pass to the mole first of the starting stuff, of the stuff we're looking for, and then finally over to the grams of what we're looking for. Every stoichiometry problem is the same, ladies and gents. Grams of what we're started with, moles of what we're started with, then to the moles of what we're looking for, then to the grams of what we're looking for. Okay? 4-step stoichiometry requires 4 fractions, so there's 1 fraction here, 1 fraction there, 1 fraction there, and finally our last fraction. The reason why I like making these maps first is because this map lays down perfectly on top of the fraction. So this map makes your numerators. Okay? 4.5 grams of NaCl, moles of NaCl, moles of CO2, Cl2, excuse me, grams of Cl2. Alright, now we have to do the rest of the setup. Grams of NaCl, excuse me. Wow, I messed both of those up. I apologize. Grams of NaCl needs to cross cancel somehow, so we need to have grams of NaCl down here. We need to cross cancel this mole of NaCl, so we need to have mole of NaCl down there. We need to cross cancel this mole of Cl2, so we must have that down there. Alright. Last year's chemistry students, as well as 2 years ago, I said this phrase a lot. Whenever you have a gram with a mole, doesn't matter if the mole's on top or on bottom, if it's gram with a mole somehow, mole always gets what number? 1. 1, 1, 1, 1, 1. Okay? So both of those are going to get 1 right there. Doesn't go here. These don't become 1 unless the equation has a 1 in it. But now we can do this next part. This is the mole ratio. Alright? Think back to set 8. Where do I get the mole ratio from, ladies and gents? The balanced equation up here. Okay? We get take the coefficients and plug them into here. In this case, the two things we're dealing with are NaCl and Cl2. So the number in front of NaCl is 2. So 2's got to go here. What's the number in front of Cl2? It's implied to be 1. In CP chemistry, we put a 1 here, but we're going to stop doing that now. You need to know that there is a 1 there. Now we just need to fill in these portions right here. Well, these portions are the molar masses, okay? These are the molar masses of NaCl and then Cl2. The molar mass of Cl2, well, 1 chlorine, let me move this over, is 35.45, but we have 2 chlorines, so we need to multiply that by 2. That is 70.90. Okay? Down here, NaCl, well, a Cl is 35.45 again, and then a sodium is 22.98. So that's 58.43. Okay? Now we can go through and solve. Multiply everything on the top, then multiply everything on the bottom, then divide the two numbers. I'm going to move down here so I can do that. Okay? 4.5 times 1 times 1 times 70.90. Okay, I don't need to show the times 1 in my calculation when I did it in my calculator, so I'll just do 4.5 times 70.90. My top number is 319.05. But how many significant, we'll get to significant figures in a minute. Okay. Now we multiply everything across the bottom. We have 58.43 times 2 times 1. 58.43 times 2. Then, yes, times 1, but that'll just give you this number back here, 116.86. Alrighty. This cross cancels, this cross cancels, this cross cancels. Okay, we're left with grams of Cl2. Alright, now, significant figures. Okay, this is division. So we are only allowed the amount of significant figures that the lowest number has. In this case, they both have 1, 2, 3, 4, 5, so our final answer has to have 5. Now, we're running out of time here, so we're going to go ahead and divide this out real quick. 319 divided by 116.86, so our final answer will be 97, because it's 5 significant figures, and the final answer is grams of Cl2, because that's what we were looking for. Alright, this one was a little bit rushed because we only have about 13 seconds left in this video, but if you need a refresher, just pause and rewind. Okay, we'll see you next for the last set, set 10. Take care, everyone.